So let's go ahead and look at a definition of scalar multiplication of matrices. If A is a matrix of order m and n, and C is a scalar, then the multiplication of the scalar and the matrix is given by CA. So technically what we do is we take this scalar and multiply it with every element inside the matrix. Now let's go ahead and see what it means now. Scalar multiplication. So I have a matrix A, -4, 1, 3, and 0, and a matrix B, -1, -2, 8, and 5. Now we're trying to find the following matrix, -6B. So what I'm doing is I am taking the scalar of -6 and multiplying with the matrix B. So that means I'm going to take the -6 and multiply it with each and every element inside the matrix. So every number inside every element inside the matrix gets multiplied with -6. So -6 times -1, +6, -6 times -2, +12, -6 times 8, -48, -6 times 5, -30. All right. So technically scalar multiplication is you take the scalar, the value, the number, the digit, positive or negative, and multiply it with every element inside the matrix. Properties of scalar multiplication. If I have C and D as scalar, so C times D times A is C times of D times A. 1 times any matrix is the matrix itself, identity. Distributive property. So if I have a C times A plus B, that is C times A and C times B. C plus D times A times D, and A times C. So technically it's just a couple of properties of the scalar multiplication. Solve the matrix equation. Now let's go ahead and look at this one. I have two matrices, 2 by 2 matrices here, and the equation is 3x plus A is equal to B. Here A stands for, this A stands for matrix A, and this B stands for matrix B. All right, so 3 times x plus matrix A is equal to matrix B. So now I'm trying to solve for x. So just like a linear equation, I'm going to go ahead and solve for x here. I subtract A on both sides, so A comes here, right? And I have divide by 3 on both sides, so I have x is equal to 1/3 B minus A. So now first I have to go ahead and solve B minus A. Remember, B and A here are matrices here. So B, which is this matrix here, and A is this matrix here. So B minus A is B minus A. So 10 minus 2, which is -12. 1 minus of -8, which is 9. -9 minus 0, -9. 17 minus 4, which is 13. And now it has to be divided by 1/3. That means every element has to be divided by 1/3. 12 1/3 is -4. 9 1/3 is 3. -9 1/3 is -3. 13/3 is 13/3. All right. Now let's go ahead and see how we can use that with RTI 83 here. So first, remember, I have to put in matrix A and matrix B. So let me just turn this on here, clear. Second matrix. Remember, I have to change the matrix, it's not the same. So the matrix A here is 2 by 2. So enter, it's 2, enter, 2. The first element is 2. Second element is -8. Third element is 0. The next element is 4. Right? Now I gotta put in B. Every time you put in a matrix, it has to be edit. Enter. 2 by 2. It's not 3 by 2. So 2. Enter. 2. The first element is -10. 1. -9. And 17. So now that I have entered my matrix A and B, I'm going to go back to the main screen. Remember what x is here? X is -1/3 B minus A. So now I'm going to have 1, over 3 times B. B is a matrix, so B minus A is a matrix, so I gotta get second in matrix and enter, close parentheses, enter. So when I go ahead and see that, it gives me -4, 3, -3, and 4.333, which is technically 13 over 3. It gives to us in a decimal value. Matrix multiplication. So let's go ahead and see how we multiply matrix. For matrix multiplication, there's one condition here. When you're multiplying two matrices, A and B, and if they're order of M cross N, the columns of the first matrix should be equal to the rows of the second matrix. It could be, I'm going to say M and P. So the condition to multiply two matrices is the columns of the first matrix should be equal to the rows of the second matrix. So now let's go ahead and multiply this matrix. This is a 2 by 2, so 2 cross 2 matrix. This is also a 2 cross 2 matrix, right? So the columns of the second matrix are equal to the rows of the first matrix. So I can go ahead and multiply. But how do I multiply? It's rows times columns. So first A times E plus B times G. And again, row times column. So A times F and B times H. Same thing again, second row times, so every row gets multiplied with every column. All right, so row times columns. Let's go ahead and multiply these two matrices here. So the 2 by 2 matrix, so the rows of the first matrix, the columns of the first matrix are equal to the rows of the second matrix. Remember, it's rows times columns. So 1 times 4, 3 times 1. That's going to be a first element. Row 1 times 1 and 3, 6 times 0. So 1 times 6 and 3 times 0. Rows times columns. So 2 times 4 plus 5 times 1. Rows times columns. 2 times 6 plus 5 times 0. And that's going to be 7, 6, 13, and 12. Now let's go ahead and see how to do it using TI-83. Alright, so let me clear this. Second and quit. I'm going to clear this one. Remember, I have two different matrices now. So I'm going to, every time you enter a matrix, it has to be edit. So enter. The order of operation, the order is, not operations, the order of the matrix is 2 cross 2. That is, that's what I want. But the elements inside are not the same. So I'm going to go ahead and change it 1, 3, 2, 5. So the second matrix B here is also 2 by 2, but the elements are different. So I'm going to go ahead and change it, which is, the first one is 4, 6, 1, and 0. And now remember, I'm multiplying my matrix. I'm going to go back to the main screen. Matrix A times second matrix, matrix B, and enter. What do I get? 7, 6, 13, and 12. Alright? Multiply the matrices. Sometimes there will be cases where you cannot multiply a matrix. Remember, for the condition to multiply the matrix is the columns of the first matrix should be equal to the rows of the second matrix. Now let's go ahead and see if I can multiply this matrix here. How many rows do I have? 1, 2. How many columns? 1, 2. So this is a 2 by 2 matrix. And this is a 2 by 1, 2, 3, 4. So it's a 2 by 4 matrix. So the columns of the first one are equal to the rows of the second one. So I can go ahead and multiply this matrix. But what do I get? These two cancel out. My final matrix will be 2 cross 4. So let's go ahead and multiply. Remember, how do you multiply? It's going to be rows times columns. 1 times 2, 3 times 0. rows times columns. 1 times 3, 3 times 5. Rows times column. You're going to stay, as long as you're multiplying the first row with every column, you're going to stay in the first row. So 1 times -1 and 3 times 4. Same thing, 1 times 6 and 6 times 1. Now let's go ahead and see how we can multiply these two using a TI-83. And again, remember, every time you enter a matrix, it has to be in edit. So I'm going to go to edit, enter. The first matrix is 2 by 2. Let me clear this up. The first matrix is 2 by 2, but the elements are not the same. So let me go ahead and enter them. 1, that's correct. The second one is 3, that's correct. The third one is 0, and then 2. Enter. Second matrix. Remember, I have to enter another matrix, which is B here. This is not 2 by 2, it's 2 cross 4. Oops. 2. Oh, let me clear it. I made a mistake. 2 cross 4. Alright, so the first element is 2 and 3, -1, 6, enter, 0, enter, 5, enter, 4, enter, 1, enter. Alright, now let's go ahead and multiply. So second A times second B and enter. Let's see if we have the same answers. 2, 18, 11, 9, 0, 10, 8, and 2. Now let's go ahead and try one more. The order of this matrix is 2 cross 4 because I have 2 rows and 4 columns. The order of this matrix is 2 cross 2. First thing, I gotta check if I can multiply. Remember, the columns of the first matrix should be equal to the rows of the second matrix. In this case, they are not, so I cannot multiply this matrix. So there will be cases where you cannot multiply them, but first you have to go ahead and check if the columns of the first matrix are equal to the rows of the second matrix. Properties of matrix. This is A times B times C is A times B times C. A times B plus C is a distributive property and associative property. Some of the properties you have to know. And hope this video is going to be helpful, and see you in class.